alternating series test. Okay, first we define what is alternating series. The series whose terms alternate between positive and negative called alternating series. Some examples are sigma k equal to 1 to infinity minus 1 power k plus 1 all divided 1 by k, which is equal to, when k equal to 1, that is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus etc. And k equal to 1 to infinity minus 1 power k 1 by k is equal to minus 1 plus 1 by 2 minus 1 by 3 plus 1 by 4 minus 1 by 5 plus etc. So in general, an alternating series has of the following two forms. The first form is sigma k equal to 1 to infinity minus 1 power k plus 1 ak, which is equal to a1 minus a2 plus a3 minus a4 plus etc. And second form is k equal to 1 to infinity minus 1 power k a raised to ak, which is equal to minus a1 plus a2 minus a3 plus a4 plus etc. minus etc. So now I define what is what is alternating series test. So there is a test called alternating series test, which is a useful tool for checking the convergence of alternating series. So alternating series test states that an alternating series of the form 1 or form 2. So form 1 is this and form 2 is 2 converges if the following two conditions are satisfied. That is, first condition is a1 greater than or equal to a2 greater than or equal to a3 greater than or equal to etc. greater than or equal to ak greater than or equal to, that is ak greater than or equal to ak plus 1 for all k equal to 1 2 etc. And second condition is limit k tends to plus infinity ak is equal to 0. So if these two conditions are satisfied, then the alternating series converges. So we will do few problems. First problem, use alternating series test to show that the following series converge. First one, sigma k equal to 1 to infinity minus 1 power k plus 1 into 1 by k. So here sigma k equal to 1 to infinity minus 1 power k plus 1 1 by k is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 etc. So this is an alternating series and ak is equal to here 1 by k. Now we will check whether ak greater than or equal to ak plus 1 for all k. So we know that k is always less than k plus 1 for all k equal to 1 2 3 etc., which implies 1 by k always greater than or equal to 1 by k plus 1 for all k equal to 1 2 etc. So which implies ak always greater than or equal to ak plus 1 for k equal to 1 2 etc. Therefore the first condition is satisfied. Now for the second condition, limit k tends to infinity ak is equal to limit k tends to infinity 1 by k. So this must be equal to 0. So the both condition in the alternating series test are satisfied. Therefore the series sigma k equal to 1 to n 1 to infinity minus 1 power k plus 1 1 by k converges. Now we will do the second problem. Okay, so for second problem, the we have to check whether sigma k equal to 1 to infinity minus 1 power k plus 1, k plus 3 divided by k plus k into k plus 1 is convergent. So this is an alternating series because this is sigma k equal to 1 to infinity minus 1 power k plus 1, k plus 3 divided by k into k plus 1. So this is actually 1 plus 3 divided by 1 into 1 plus 1, first term, second term, minus 2 plus 3 divided by 2 into 2 plus 1, etc. So this is an alternating series, and here ak is equal to k plus 3 divided by k into k plus 1. Now we know that we have to show that ak is always greater than or equal to ak plus 1. So this it's enough to show that ak plus 1 divided by ak is less than 1. So this definitely implies ak plus 1 is less than or equal to ak, right? So for that, I will take ak plus 1 divided by ak, which is equal to, so what is ak plus 1 here? Instead of k, we will put k plus 1. So k plus 1 plus 3, k plus 4 divided by k, instead of k, k plus 1 into k plus 2, all divided by ak. Ak is simply this, k plus 3 divided by k into k plus 1. So this is equal to k plus 4 divided by k plus 1 into k plus 2 into k into, we will take reciprocal of this, k into k plus 1 divided by k plus, so and k plus 1 and k plus 1 get cancelled. So 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 here I will cancel it out here, and if I multiply this into k, I will get k square plus 4k divided by k square plus 5k plus 6. So k square plus 4k divided by k square plus 5k, you can written as k square plus 4k plus k plus 6. So this is less than 1 since no denominator is greater than, strictly greater than numerator. Therefore, ak is greater than ak plus 1 for all k. So this first condition is satisfied. For second condition, limit k tends to infinity ak. This is equal to limit k tends to infinity k plus 3 divided by k into k plus 1. So for that, what I will do is limit k tends to, I will do here, k tends to infinity plus infinity. I am taking out k square into 1 by k plus 3 by k square. Okay. So if I take out k square here, k square into 1 by k plus k square into 3 by k. And if I take out k square from here, you will get 1 plus 1 by. So if I cancel out k and k square and k square, I will get this. As k tends to infinity, this will become 0 plus 0 divided by 1 plus 0. So this is equal to 0. So the limit k tends to infinity ak is equal to 0. Therefore, both condition of alternating series test satisfied. Therefore, the series B is convergent.